All right, we're going to be moving on to our next module, which is talking about building a little bit larger structures. As we start to design full products, you kind of think of a full product as being like a vending machine, a stopwatch, something that you can like physically hold in your hands. These become very complex circuits. And when we start viewing these complex circuits, we need better ways of understanding all the internals that are inside. So what we really want to do is try to view the circuit in some type of abstract piece. So we've done a couple of different circuits before. Here's one example. We wanted to build a 1-bit adder. And in this 1-bit adder, the circuit we built looked a little bit like this. The 1-bit adder had 3 inputs, an A, a B, and a carry in. It had 2 outputs, a sum and a carry out. And how do we go about building it? In total, it ended up being this 5 gate system here with 2 XOR gates, 2 AND gates, and an OR gate. And if we're going to start building, complex circuits, let's just say we're building a calculator. Eventually, we know that calculator has to be built with, we're going to do like 8 bits of this adding. But when we add these at the end, we're going to need to see all the different OR gates, AND gates. But as the designer, we're trying to figure out how should this be created. We don't necessarily need to look at the gates. We want to have that the designer, we want something that's more readable. And the more readable part is that leads to our abstraction. So you say, can I view the circuit as a whole? Items that we can kind of use in a circuit for these abstracted pieces, there's a number of different names that we can use. Some are called that it is a black box that we use. You can say it's a building block. You can say it's a module. You can say it's a component. There's a lot of different names that can be used, but it's the idea of moving to something that's abstract. So here we could say the 1-bit adder, the abstract view is this little box here. So that's the abstract view. The designer just needs to know, look, I'm going to have an adder. I understand how the behavior of the adder is going to work. A, B, C, if they're all zeros, I'm going to get 2 zeros out. If they're all ones, both the sum and the carry out is going to be a 1. The designer knows the behavior, and when they need to build it, they can go and look at the circuit at a later time. So one common building block that is widely used is called the multiplexer. And if you start looking at very complex circuits, you're going to see a few of these probably in the final design. The common name that a lot of people use instead of multiplexer is just MUX. And the MUX can be used in a number of different ways. The primary way it's used is as a switch. And there's other ways that we can kind of use it to create a Boolean equation. And we'll do that in a different video. It's kind of like a trick. You can kind of think about it. It's not the main goal of how a MUX is being created. So the switch that we're going to do is really down to sharing of resources. So let's look at an example, something that we're all familiar with. So let's say we have a TV. You have this in your living room and your bedroom. And on this TV, there's one display that you have, but you have a lot of devices you want to connect to that display. Maybe you have like a Roku stick that you're going to watch Netflix on. You have a PS4, an Xbox, and you want to, at any moment in time, switch from one device to the other. Now, if we only have one display, it doesn't mean that if I want all 3 devices, I got to have 3 TVs. None of us have that. What do we have is, through some type of HDMI cable, we connect all of these devices to the TV. And depending on how many slots we have open is how many devices we can have. And then what do we do is, somewhere on the remote, there's some switch here to say which input we want. Input 1, input 2, input 3. And we're going to use this remote to, switch between the different devices we have connected. And what does this save us? This saves us that all we need to do is buy one TV, because likely we only have room for one TV. We only have the money for this one TV, but we want to have a lot of pieces connected. The same thing can be viewed as a circuit. Let's just scroll back up real fast. And let's say we have this 1-bit adder. And we know in our circuit, we're going to be doing a lot of addition, but it's all at different points in time. Instead of duplicating this adder 4, 5, 6 times, if it's possible, let's have those 4 or 5 times that we need it all share this one adder. Kind of the same way as I have all these devices. How am I going to get them to show in my living room? I'm going to have them all share one TV. So the MUX for us is usually described as something that's 2 to the n to 1. So what does that mean? Let's say n is equal to 1. That's going to give us it's a 2 to 1 MUX. If it was n is 2, that's a 4 to 1. N is 3, 8 to 1. And it keeps growing in powers of 2. So the next size would be 16, 32, 64. So how do we go about drawing these items? Okay, so we're going to have our input, we're going to have our output. So here we're going to do a simple 2 to 1 MUX. It has A and B, and then it has the Z. Think of the Z as your TV. Your A is your PlayStation 4, your B is your Xbox One, and you want to switch between them. How do we switch between them? In the example with the TV, we had the remote control. We had some input that we could switch through. The same thing is going to happen. And let's just say it's an S here. We're going to say this is our select. So it's going to be an additional input for us. Now, I want to describe how this MUX is going to work. So we're going to describe the MUX. It's going to look like a truth table, but we're not going to build like a K-map from it. This is usually what's called a characteristics table. Just kind of explain how the circuit is going to be created. Now, this is going to look different in that the one side is the same. We still have our output. But on the other side, we're only going to have S. And the reason we're going to have S is this is not going to build the circuit for us. It's going to explain what it is that we want. On this S here, we know this is, binary. There's a 0 and there's a 1. And we're going to use that 0 and the 1 to select which one of these inputs here. Is it the PlayStation 4? Is it the Xbox One? That's going to be connected to the TV. So we can kind of think of the top as being the 0, the B as being the 1. So when we describe it, we're going to say, okay, when S is 0, Z, or the output, is getting A, which would be like our PS4. When the S is 1, we're going to get B. It's going to be the Xbox here. You can see that this is not the same as a K-map. In a K-map, we would expect the Z to have 0s and 1s. And here they have letters. The letters are what is it that we want connected. Okay, so then let's move down. And here's another example of a 4 to 1 MUX. Have A, B, C, D. And then we have our Z. Well, again, we're going to need some type of select. But now, is 2 options going to be enough for us? No, because if we look here, we have 4 options. So 4, if we look at 2 bits, that's 0, 0, 0, 1, 1, 0, or 1, 1. That's going to cover all the options that we're going to have. So here, we're going to need that S is going to be 2 bits. And as we do our abstraction, and we're going to use these block diagrams, the black boxes, how we're going to show multiple bits is the lines will have a little slash through it, and then you put the number of bits next to it. So here I'll have a /2. All right, so let's kind of describe this one. We're still not doing a full K-map. It's just our S, which we know is 2 bits. So that's going to give us 0, 0, 0, 1, 1, 0, or 1, 1. And then we say, what do we want the output to be? 0, 0, we want it to be A, 0, 1, B, 1, 0 is C, 1, 1 is D. Think of this table as like a guide. It is, the selection that as we built the circuit, the designer's going to need to know this information because eventually they're going to put it into a K-map to solve our circuit. So if we were going to do one more, let's just say we're going to do an 8-to-1. Let's just make sure we have the idea of how this is set up correctly. I'm going to have an A, a B, C, D, E, F, G, and H. I'm going to have all of those inputs is 0, 0, 0, 0, 0, 1, all the way down to 1, 1, 1. So that means that S here is going to have to be 3 bits. I put a slash across the line and I put a 3. That's going to tell us it's a 3-bit value. Okay, so now we have the idea of what a MUX is, but we are the designers. We need to know exactly, I see this box, how am I going to create it? So let's start with the one that's the easiest, the 2-to-1. And on this 2-to-1, we see we have an A, we see we have a B, and then we have a Z. Now, as we view this circuit, let's go back to some of the early stuff we did in the class when we did little stick diagrams. So let's say here, I'm going to have my A and a B. I know my output is going to be Z. And here is, there's some selection here that I'm going to select. How do I want it to be connected? So if S is equal to 0, I want that A to flow all the way through to Z. Or if I wanted A not to go through, I want it to be the connection, I'm going to make S equal to 1, and then it has a flow all the way out to Z. So we've seen some of these, like when we did it as little bridges. So these were the 2 options that we have. What do 2 options usually say as a circuit? The 2 options as a circuit, most of the time we think of that as being some type of OR gate. I want this or that. Okay, so we have an idea of what a circuit was. You know, when we did a circuit and we did it as those little bridges, we said, okay, that was going to be something that was going to be parallel. You know, I had 2 options. I'm going to have an option for S is equal to 0 and an option when S is equal to 1. So if I take that logic and I try to build it, I'm going to have my A, that's controlled by a bridge. Is A a 0 or is A a 1? And then that's going to be connected to this S. And here we're going to put it with a bar because when it's 0, I want that bridge to go down. And then that gets connected to Z. On the other side, I'm going to have my B. And then that's going to be connected to the bridge that has the S in it. Okay. So what was the circuit? If we look at this diagram, what's the circuit? The circuit is A S bar or BS, and that is the Z. So that's how we would go about building this. You know, we could also kind of view it as on this table here that we did. Well, if I look at this item here, I kind of expand that out. Here's the A, and how is A selected? With S bar. And then the next one is B, and how is B selected is with S. And then I know these go through an OR gate. So I get A S bar or BS. All right, so then let's take the idea one more time with a 4-to-1. So here I have A, here I have B, C, and D. Now, when I do this and I have my S and it's 2 now, I'm going to have to view this S as being 2 bits. So let's do it as an S1 and S0. I'm going to use the subscript to tell me which bits I have. So I do this little diagram. I know if S1, S0 is 0, 0, I go to A. If it's 0, 1, I go to B. If it's 1, 0, I go to C. If it's 1, 1, I go to D. Well, let's take the same idea. What is the first line? The first line is A, and that is when S1 is 0, so that's a bar. S0 is a bar. B would be S1's a bar, and S0 is a 1, so that's just by itself, no bar. C is S1, S0 bar, and then D is S1, S0. So I built that as a circuit. All of these get ORed together. So I get A, S1 bar, S0 bar, plus B, S1 bar, S0, or C, S1, S0 bar, or D, S1, S0. So we can see that building the circuit, still kind of using this characteristic table to help us to get there. And all we need to kind of view is to understand the process that is happening. How do we get to that process? Go back to the very early stages where we look at, seeing how electricity flow through the circuit. We understand the way the bridges need to work. All right, so that's the way we built these the 4-to-1, the 2-to-1 muxes. That gives you an idea of how we use a mux as a switch. Later, we're going to view it as how can I use this in a different way, like an a branded way, kind of like a trick to do Boolean logic. All right, so I'll see you in the next video.